All right, so I just wanted to go through a couple of these problems. The first, for the most part, the first few are pretty simple, but again, worth reviewing. Um, and we're going to get into more depth in this. So, chapter 6 is very much an introductory chapter. Um, it's kind of a mile wide and an inch deep, as they say. So, number one, it's saying that this person investigated a relationship between the number of hours spent studying and the test score for some of the students in her class. She constructed this scatter plot below. And what you can see in this scatter plot is there's obviously what we would call a positive correlation. So I can very, very, sloppily kind of sketch the trend line there. So it's just a sketch, right? But we can clearly see that there is a relationship, right? That we would say that there's a positive relationship, in fact. So you could cross off A and B. In fact, let me switch to my red pen. That way I mean business, right? We can cross off A and B because A and B are saying there is no relationship when we can clearly see that there is. There is a relationship, and we can actually tell that as we spend more time studying, as X increases, we see that our test scores are also increasing, right? It's a positive slope. On the other hand, in a question like number 2, or an exercise, whatever you want to call it, this is what we would call a negative correlation or a negative slope. You can see the trend line is going down as we move from left to right. We read our graphs like books, right? From left to right, it seems like as temperature increases, that's our X variable, right? Temperature in degrees, the number of visitors at this zoo is decreasing. As it gets hotter, as the temperature increases, less people are going. The visitors decrease, right? So nothing too crazy yet. Let's keep moving. A couple things really quick about 5, 6, and 7. These are kind of difficult problems too. I just want to talk about them really quick. What type of association is shown by the scatter plot? Again, some of the most what I was seeing a lot. One of the most common mistakes I was seeing is that there was linear and strong. So just a quick reminder: in math, when we say the word linear, we mean straight line. Straight line. That's what we mean. Linear means straight line. And so that is to say non-linear, right? This is obviously a curve, right? And as to whether it's strong, I'm so sorry, my computer has been, ever since I updated to Windows 11, I swear, I've been having so many problems. But obviously we could see it follows a curve. Now, how closely does the data follow that curve? Well, all the points are touching the curve, right? So I would argue that's pretty strong. Strength of association is something that we're going to talk about more in Chapter 7. We're actually going to put a number to that. It just describes how closely the data correlates, or how closely it clusters to the line. So we're going to come up with some some things called residuals, and that'll allow us to talk about strength of association in an extremely rigorous way, which is good. Number 6, this is a common problem. I think there's a little bit of a typo here. It should say or. But as you can tell, that this is neither positive nor negative, right? So this is a situation where we actually have what we would call a zero slope. Zero slope. So if you think about, if you've ever been on a treadmill, when you get on, it's perfectly flat, right? And you would say that there is zero incline on that treadmill. It's the same idea. A perfectly flat, quote unquote, linear association. It's actually zero slope. And so there actually is no negative or positive correlation. And I just really quickly want to, we would actually say that there is no correlation whatsoever between those two variables. And to demonstrate that, I want to give you a really quick example. So, when I graduated high school a million years ago, the average age of high school seniors Average age of high school seniors. Right, the average age of high school seniors, well, it was about 17, right? You know? And we could talk about our x variable. So that was our y variable. And let's say our x variable is the year. Right? So, you know, even in 1950, right? All the way up to, let's just call it 2030, because it's not really going to change, you know? That average age is still going to be about 17. And even though the data might go up some years, sometimes it might be, you know, a little bit higher, sometimes it'll be a little bit lower, right? It doesn't really matter, right? The truth of the matter is that it doesn't matter what year it is. I'm so sorry. I really, really, really can't stand Windows 11. What is happening? What is going on? Sorry, guys. Man, computer, why are you failing me right now? That's so terrible. There we go. Right. It turns out that it doesn't matter what year it is. It doesn't matter what year it is, does not affect. Why are you doing this? Oh my Lanta. I am so sorry, you guys. You've got to be joking. I'm so sorry. It does not affect age of high school seniors. That is to say, that as the years increase, the average age is not also increasing, right? It's staying the same, right? As opposed to something like exercise, right? Now, exercise is often linked with positive health outcomes, right? So the more you exercise, obviously, the more positive health outcomes you will enjoy as a result. Yeah. So number 7, let's talk about number 7. Now, it's saying which 2 points. So if I were to draw a line through any of these 2 points, which one would yield the best, right? So I think we would all agree that this red line that I just drew is a very bad representation of a trend line for that dot plot. Our trend line for this plot is probably going to look something like this, right? Probably something like that. And so it's saying, well, through which 2 points could we draw a trend line? Let's look at A. Let's do 2, 1 and 3, 1.5. So there's the line going through those 2 points. I could kind of fix that a little bit, right? And it's not great. It's a little too positive, if you ask me, right? It's a little too, the slope is a little too steep. So let's cross out A. That's not quite it. Let's try B. 2, 1 and 5, 2. 2, 1, again, right here. 5, 2, again, right here. So let's draw a line through those 2 points. Come on, give it to me. There we go. There we go. Right. So I think that's a much better. In fact, it turns out that there's a whole nother point that ends up to being on this trend line. So we have we have 2 that are above-ish. We have 2 that are below. And it turns out that we have actually 3 points that are actually directly on the trend line. So I would say that 2, 1 and 5, 2 are very, very good points to draw a trend line through. Right? So that one's just kind of trial and error. Try a couple, see which one seems the most accurate. Let's do number 9. And in fact, I'm going to go an extra mile on number 9 because I want you guys to practice on number 10. So obviously, the problem was just asking you to find the slope. What I'm going to do is I'm actually going to find the whole equation. And in order to do that, in order to find the equation, well, I need to find m. I also need to find b, which is our y-intercept. So find b, which is our y-intercept. And then we'll use the point slope formula. Not point slope, I'm so sorry. Slope intercept formula to, we'll use slope intercept formula to write the equation of our line. Right, where m is our slope and b is our y-intercept. So the first thing we need to do, I'll switch to my white pen. The first thing we need to do is actually find our slope. And, you know, I don't want you guys to freak out too much. Finding the slope is very, very simple. Remember, our ordered pairs are always of the form x comma y. Right, x comma y. So 4 is an x value, 21 is a y value. 8 is an x value, 35 is a y value. So when I do my slope formula, right, big fraction bar, and we'll do, really, this is just going to turn into two small subtraction problems. So I'm going to start by subtracting my y's. Remember, it's rise over run. 35 minus 21. Right, and you'll notice that I started with 35 on top. That means I need to start with 8 on bottom. Right, when I do that, I end up with 14 over 4. I can reduce that to 7 over 2, and of course 7 divided by 2 is 3.5. My slope is 3.5. Either one of these, honestly, all three of these are correct, and it's so funny because it turns out that when we actually do this problem, it turns out that 14 over 4 is actually the easiest way to find the y-intercept. So let's actually find our y-intercept now. We found our slope. How lovely. And I'll kind of show you what I mean by 14 over 4 is like it's a little bit easier. It has to do with this 4 right here. So let's actually box this 4 comma 21, because that is the x and the y that we're actually going to use. So our m is 3.5. We're going to use 4 for x, and we're going to use 21 for y, and we're going to plug all these numbers into our slope intercept formula, and we're going to find b. Now, looking at this graph, I actually already know what b is, right? Remember, b is our y-intercept. It's where we cross this vertical that, oh my lord, that is certainly a line. Oh my lord, so sorry about that. Let's pretend that didn't happen. This red line, that's what we call our y-axis, correct? And so what we're trying to find actually is where this line crosses our y-axis. And you'll notice that it crosses just right above 6. And I want you to keep that in mind as we find b. So it crosses right above 6. So let's write down our y equals mx plus b. We'll do a little bit of color coding. You know, I think color coding is great. Unfortunately, I don't have a color printer. Otherwise, you know, I'd give you guys everything color coded. But yeah, you know, I do have some highlighters in the back that you guys are obviously more than welcome to use. Anything that helps get the point across, right? So it turns out that our y is 21, our m is 3.5, and I'm actually going to put parentheses around that. Our x is 4, and we're saying plus b, and I'll do b in a different color. So our 3.5, our 21, our 4, which is our x, and I'm going to do this pink for our b, or this kind of dark pink. It turns out that 3.5 times 4, so we're going to do a little bit of algebra. 21 equals 3.5 times 4 comes out to 14 plus b. We are still trying to figure out what b is. Oh my gosh, sorry. can't color code down there because technically I'm off the paper, so that's a little bit silly, but whatever. Um, and technically you have to do a little bit of algebra. That's what a math teacher's supposed to say. But think about it. What number, right? 14 plus what gives us 21? 7, right? And when I say 7, when I say that b is equal to 7, isn't that really, really close to that 6 right there? Isn't it slightly just above that 6? Makes you think, doesn't it? Our last step is simply to take y equals mx plus b. And again, we're going to replace our m and our b. Our m being 3.5 times x plus our b, which we just found, right? So very simple. That is our final answer. Again, sorry, I can't color code down there. If I try, let's watch what happens. If I try to do it, I'll just color the whole thing, which is, again, I think it's an issue because, yeah, like that. Anyways, that's correct. Again, on that question, I was just asking you to find the slope, but I was just asking you to find the slope. I wanted to go ahead and do the equation for you. Let's do number 12 really quick, and then we'll call it a night. So number 12, Marquise wrote a, oops, come on. Jesus. Marquise wrote a linear regression equation. There it is. Right there. To predict the cost, which we put in y. So the cost in dollars is our y value. The number of songs, the quantity of songs that he bought is our x value. And so we're trying to find the number of songs that he purchased, right? That's actually, we're solving for x. So what we're going to do is we're going to substitute 40 in for our y variable in this case, right? So we're actually going to just copy this equation down. We're going to take this equation, and we're actually just going to, instead of y, we're actually just going to put 40, right? So we're literally just going to take that 40 and we're going to plug it in right there for our y. So instead of y equals, we're going to say 40 equals 1.245x minus 3.684. And we have to do a little bit of algebra. Now, plugging in numbers for x is typically a little bit easier, just in my opinion. The algebra is just not quite as annoying and difficult. In reality, it's hardly even algebra once you plug in for the x. For this one, we're actually solving for a variable, so it's a little annoying, but I always like doing algebra. To me, it feels like cleaning. You ever just have a large pile of dishes? So you get it all done, you clean the sink, and you even go the extra mile and you wipe the sink down. There's just nothing quite as good as that feeling of just having a nice, clean kitchen. And so I added 3.684 to both sides to get rid of this guy. That works, obviously. I was left with 1.245x times x, I should say. So I divided both sides by that 1.245, and since I've done this problem many times, I actually get that when I do 43.684 divided by 1.245, I actually get that x is approximately 36. And because we're using math to communicate and understand the world better, it's always good to connect this with literacy. So make sure you write the sentence down. When Marquise bought 36 songs, he spent $40. Or when Marquise spent $40 on about 36 songs is what you would say, right? So nothing too bad. I hope this helps. Please let me know if you have any issues. shoot me a message, talk to me, anything you need. All right, I'm an open book. Thanks for watching, and I hope you have a nice day. Bye bye.